Hello. So this week's assignment is going to be basically an extension of what we covered last section, where we talked about connecting to the PLC. Last time I spent a lot of time talking about the different connections, power, inputs, outputs, communications, etc. And I had you start practicing creating input-output diagrams and thinking through the concepts of syncing and sourcing. So I'm just going to give you an overview of the trainer that you're going to start working with on this first in-class session. As you can see up in this corner here, we have your new processor. This is a MEC232. Got the power supply on it. For some of your outputs are going to be running these two relays, one of which you're going to use to turn on and off this DC motor, and the other one of which you'll use to reverse the DC motor. So we'll talk a little bit about that today, just reviewing how DC motors work, about reversing those. You can also kind of see up in the corner, let me shift it a little bit, there's a stepper motor driver and a stepper motor down in the corner. There's going to be a few of the proximity sensors, inductive proximity sensors that we talked about, or at least one. And you'll be building this in phases, so you might not necessarily be connecting all these components up, not necessarily, like for sure you won't be. This week we're just going to focus on some basic I/O, and then later on we'll add the stepper drive and stepper motor and things like that. So in addition to these, so far we've looked at output devices, there's also going to be kind of an I/O panel here. Well, you'll have a number of illuminated push buttons and toggle switches, and later on you'll add an analog meter and a potentiometer that we'll use to control an analog input as well. So let's go ahead and look a bit more at some of the components I want you to be using, or starting to think about how you're going to connect to your PLC. So the first one, your main input device for right now, is going to be these illuminated push buttons. So they're momentary, they're not maintained. They have a common terminal, a normally open, and a normally closed. So they're single pole double throw, and we'll talk a little bit more about that in a minute, just reminding ourselves what that means. So that's those three terminals that are in a line across there. And then you'll see there's two more terminals, and that's for the illuminated part. So these are kind of nice push buttons in that the illumination is independent of the press of the button. It's not that it turns on when you press the button, the lamp turns on when you put voltage on these upper and lower pins. And when you get yours and see them, you'll see that this pin down here, the furthest one away, is marked negative, and this one up on top is marked positive. So keep that in mind. That's one of the devices you're going to be using. Another one is this 3-position toggle switch. So in your last trainer you had a 2-position toggle switch that was either down or up. This one now has a middle position, and that makes it a little more useful. Before, we really only needed one wire, right? The switch was either on or it was off. Now it's on in 2 different positions. So we can have a middle position where neither contact is connected to the common, or we can turn one way and we'll connect, in this case, maybe the purple wire, go the other way, we'll connect the yellow wire. So with one switch here, we're getting 2 different inputs to our PLC. And we're actually going to connect both of those inputs to our PLC. On the push button, we're not going to connect both the normally open and the normally closed, because on this device, only one of those is going to be connected at a time, so it doesn't make much sense to wire them both as inputs. I hope that makes sense what I'm saying. If I push the push button, normally open is now going to be connected. If I release it, normally closed is connected. So as you hopefully are very comfortable with by now, from a PLC perspective, I don't need to have both the normally open and the normally closed connected in that case. I can use just one, and if I want to flip the state of it, I can do that in the PLC. So just to refresh, that's different than this one, where it has 3 different positions. So up and down are independent of each other. I can have it not connected to either one, so in this case it actually is 2 separate inputs. Okay, you have one of the other components we'll be starting to work with is this 24-volt DC relay. So I'll give you the part number and you can look up the details about it, but this is a 2-pole. So if you look at the contacts, there's a set of contacts on this side and a set on this side. So looking down through it, you can see there's two sets. So we're double pole and it's double throw in that there's a normally open and a normally closed contact. Again, it's probably a little hard to see on the camera there. As a reminder too, we're talking about 24 volt DC relays, and if you remember how a DC relay or any relay works, there's an electromagnet in there. You can see it, kind of that copperish color. That's the winding of a solenoid that is moving the lever arm with the contacts on it back and forth. So what we do is we connect an output of our PLC to the coil, and when the output of the PLC turns on, then the coil will energize and it'll toggle our relay contacts. And we do that so that we are wearing out the contacts of this relay external to the PLC rather than internal to the PLC transistors. And the transistors in the PLC are good for about an amp, whereas this I think is rated for 8 to 10 amps. So you're going to use that, but if you also remember back to MEC232, what happens when you have an electromagnet with a magnetic field around it and you turn off the current that's energizing that field? Hopefully it'll ring a bell that magnetic field collapses, and as the magnetic field collapses, it induces an electric voltage into the coil. So when that field is collapsing, it actually creates a back feed voltage on the circuit, and it can get really high. It can be hundreds of volts, and it can fry your output of your PLC. So we need to use a device to protect the outputs of the PLC from that spike. And again, we talked about this briefly back in MEC233. The way we do that for a DC supply is we put a diode across the coil so that the diode blocks current flow in the normal direction when we are powering the relay, but then when we remove power from the relay, it allows current, that back EMF force, to flow in a circle and dissipate itself within the relay. So we'll go over that schematic a little bit, but I actually might just send you on a reference to go look up that. And then the last thing we'll talk about today is this little DC motor. It's a 24 volt DC motor, and so this is the motor part right up in here, and it has a gear head on it. So if you look at the label here, it says the motor itself is 3,500 RPM, but then once the gearbox reduces that down, we're at an 85 RPM. So it's a nice kind of safe, slow speed with a fair amount of torque though from all that gear reduction. So one of your tasks this week is going to be researching and coming up with a schematic for how to reverse a DC motor using a relay. Okay, I think that's enough of an overview of the components we'll be using this week. Okay, so let's look at some of the details of the devices you're going to be using so that you can use a schematic that's consistent from each of your diagrams. So again, momentary illuminated push button. If we look at the back of it, it has a series of terminals, kind of a row of 3 that are the push button contacts, and then 2 perpendicular to those that are the lamp contacts. So looking at it, this one at the bottom is the positive for the LED to illuminate it, and this one up here is the negative for the LED. So those 2 are independent of the others. And looking down then on these other ones, if we're in this orientation, this one right here is the common of the push button contacts. This is the normally open, and this is the normally closed. Okay, so let's talk about the schematic for that. So for this inner set, the button contacts, like I said a minute ago, that is a single pole, meaning there's one common that can go connect to other devices, and then a double throw, meaning there's 2 different options that common can connect to. So looking at it on a wiring schematic, it would look something like this. That's our common terminal, and then we'd have our normally open and a normally closed. So there's the contact, something like that. and then we can connect the normally open onto other devices and our normally close. So when you're drawing schematic, if you needed to draw the whole thing, you could draw it like that. But since we're just using as a push button, we'll use the push button format, which is more like that. And we're just going to use the normally open of the push button style for right now. So you can use that. This would be your common terminal, and this would be your normally open terminal. So this here is how I would like you to represent the contacts of the push button that we're using right now. For the lamp side, it's an LED, so we'll go ahead and use the symbol for an LED on our schematic. And that is, if you remember, LED stands for light emitting diode. So the schematic for a diode is just a triangle with a bar on the end of it, and then we add little arrows that show light is coming off of that. So that's our schematic for the LED, with this being the positive and this being the negative. Okay, so that represents pretty much everything you'll need for this device. Then let's look. The other one we're going to work on is the toggle switch. So this one, the schematic would be more like what we showed up here. It's a 3-position toggle. So you can represent either up and down as 2 separate switches, which is probably what I would, we could do it different ways, but I would probably represent it like this, with this being the common, and then having 2 different positions. And neither one is considered normally open or normally closed here because we have a middle off position. So now we're just going to have a terminal, and this, you could label this one up and this one down, and then those could go to 2 different inputs on your PLC. So there's a representation we can use for the toggle switch. There's another way you can draw that if you want. This is, if you think back to our MEC232, this was another way they did that. Draw it looking more like a selector switch, dashed lines, and then you would show something like that, and then label them. One is up and one is down. Okay, I think that's good for those 2 devices. So let's take a better look at the next device we're going to be connecting to the PLC, and that's these relays. You're going to have 2 of them. They're identical. Contact wise, it'll be real similar to what we just talked about. As far as the contacts, you'll have a common, and it will have a normally closed and a normally open that you can then connect onto other devices. And I will give you the part number for this in your assignment that you'll be able to look up the schematic. You can also read it here on the side, but I want you to practice looking up the documentation for it. So this shows the contact side of the relay, but then we also have the coil side, right? We're going to have often we call that control relay in there, and since it's a DC coil, it's going to have a positive and a negative side, and that's a positive and positive, that's not real helpful, a positive and a negative side. And sometimes it doesn't matter which you hook up, positive or negative on a coil, but in this case, as I talked about, we need to protect the outputs of the PLC. So again, let's talk a little bit more about what's happening when you have the solenoid inside there, which is just an electromagnet, right? A big coil, which hopefully if you think back to MEC131 and MEC133, if there's a big coil of wire, that sounds like an inductor, right? And so when current flows through an inductor, it creates a magnetic field around it. And that's, in this case, we're using that, right? There's a solenoid running, or an armature, sorry, running through the middle of the coil that's then connected to our contacts, right? This is the device that's actually moving our contact bar. I showed you an example of that in last week's discussion. So when that field, so when we're using the field to move the armature, we're using current flowing through the inductor to create a magnetic field. When we remove that current by turning off the relay, it works backwards. So now that magnetic field that was created by the current, now that magnetic field, which was, if you think about magnetic fields, are kind of loops, right, north and south poles. Now that field is going to collapse down. And so instead of before having current creating the magnetic field, now we're going to have the magnetic field collapse, and it's going to generate a voltage spike. And if this was positive and negative before, it's going to be the reverse of that. So if we were feeding it like this, voltage and current, conventional current, when we're supplying it to the coil, it's going this way. When the field starts collapsing, it reverses. Because instead of being generated, now it's generating. So now the flow is the reverse of what it was before. And that's important to note because we're going to put a diode around this coil here so that when that flow starts happening like this, we want, instead of that voltage trying to push through our insulation back in the PLC and maybe fry our transistor, we want to just give it a path so that it can just keep dissipating in a circle here, basically. It just wears itself out on the resistance of the coil. So what we would do in that case is put a diode that blocks the way normally. So thinking back to diodes, we had real kind of discussion about those back in MEC232. Diodes flow, they allow current to go in the direction of the arrow. They block it when it comes the other way. So when we are connected in our normal, when we're supplying power from our PLC, so voltage and current are coming this way, they can't go through the diode, but they can go through the coil and energize the coil. Then when we remove this feed from the PLC, now that spike starts building on the negative side of the coil. Remember we said it's the opposite of when it's being fed. So if this is the positive side from the PLC, when we remove power to the coil from the PLC, then this side starts building up. And so there, now that positive voltage can go in a circle, kind of like this. And that allows that voltage and current to just kind of dissipate, getting slowly used up on the resistance of the coil. So there will be a module on your relay. I don't have one right now on this one, but you'll be able to unplug your relay and you'll see there'll be a little diode protection module that plugs in right here, and so it provides this function here. And you can see you don't have to have that. Like right now, if I just wanted to power this relay off of a power supply that's not sensitive to that back EMF spike, I could just hook up positive and negative to these two terminals and not worry about the diode. But since we are hooking up to something fragile, we need to pay attention to that. Okay, so I will have you, I'll send you the information about this relay and probably have you look up the part number for what the appropriate diode would be for that. Okay, so you're going to have two of these. One of them is to turn the motor off and on, and the other is to reverse the motor. So let's take a look at our motor itself. Okay, so here's the DC motor you're going to use. Like I said, it's 24 volts, got a gear head on it that reduces it down to 85 RPM at the output shaft here. We'll already have a pigtail on it that you're going to be using to wire up. But let's talk about reversing a DC motor. They're one of the easiest types of motors to reverse. So if you look at it, it's pretty much just going to be, looks a lot like a control relay coil, only we put an M on it. If this is our positive and negative, that's going to rotate in one direction. If we swap those, so we'd say positive and negative this way, that would maybe give us rotation like that. And vice versa, if we do negative and positive this way, we'll do that. So all you need to do to reverse a DC motor is switch which end the positive is connected to. There's a couple different ways to do that with a relay, and part of your assignment today will be researching one of those two ways. When it comes time to actually wire it up, I'll tell you which one I want you guys to do, but I want you to go out there and research how to connect it. But I'll just give you the heads up. You're going to use a coil control relay just like the ones we just went over, and I guess talking about that, looking back up here at this set of relay contacts, this would be called single pole double throw. We already talked about that. In reality though, this relay is double pole double throw, so it looks more like this. So it's two sets of contacts mechanically connected. When the solenoid moves one set, the other set moves with it. So you have two commons that can choose between two different positions. So again, just to review, the fact that you have two commons, two potential paths, that means double pole. The fact that each of those paths has two different potential contacts means it's double throw. So this is a DPDT, whereas up here we were single pole double throw. That's all review, but never hurts to go back over it again. Okay, we've gone over our relay, we've gone over our gear motor, we talked about push buttons, and we talked about toggle switches. Last one that you're going to be wiring up this week is the proximity sensor. So again, we had this schematic here. I'll give you the part number so you can look up the data sheet. Hopefully you're feeling pretty comfortable about that from last week. But there's the schematic for how we would represent this sensor. It's going to need a positive 24 volt supply. It's going to need a negative from that supply, and then it is going to have a signal line that you're going to connect to your PLC. Okay, that's it for devices. Okay, so here's your assignment that will be due Thursday evening. I would encourage you to get as much done on this before Wednesday's class if you can, so that if you have questions you can ask them when we're in person. It might be easier to address them quickly. But this will be due Thursday evening. There's two components to it. Well, there's a couple components to it. The first main half is creating a schematic for how you're going to connect your inputs and your outputs to your PLC. Real similar to how we did the last assignment. Just show me the terminal numbers on the PLC. It can be basically a black box. Let's grab a piece of paper. Show me the input, 0, 1, 2, 3. Break those up and then show me the devices connected to them. Say maybe I had a push button on this one. And let's see, what else do we have? We could have the proximity switch on that one. Then down here, again, 1, 2, 3, on for all the terminals that you need. Say this one I think is power to the PLC. This one's negative, so you would label your DC power supply. That kind of thing. And then on the output here, one of them I might be going to an LED, so I could draw my LED like we talked about. Little arrows showing light comes out of it, and then since these have color I could write underneath it red. And then this end would go to the negative DC power supply. One of them go to the control relay coil. You get the idea. Basically, we're looking for from power supply through inputs, outputs, and back to ground. So I can see your circuits for all your inputs and outputs for the list that I'm going to give you here. And these now are the actual components that you'll be starting to connect on Wednesday, and we'll have connected up by Thursday is the goal, so that you can run a basic program through them. So here's the part numbers for the devices that you need part numbers for. So the relay that you're going to be using is a 782-2C-24D. That's the relay body itself. And that means it's a 782 series. The 2C stands for the 2 poles, and 24D means it's a 24 volt DC coil. That is plugged into a socket, still the 782 series, still 2 pole, and then just SKT for socket. Okay, so the first task for you is going to be find on Automation Direct, these are both Automation Direct parts, using their website and the technical specifications documentation for this relay and socket. I want you to find the right part number for a diode protection for this relay. And so just find the data sheet for this relay, read through it, and you will see them talking about this. And so you're looking for one for 24 volt DC. The data sheet for this relay will have 120 volt AC options, etc., and those use MOV suppression or surge suppressors, but we're just looking for basic diode. So your first task is to find the part number for the diode protection module that plugs into this relay. Okay, the other Automation Direct part you're going to be using is a proximity sensor, and that is APS4-12M-E2-D, and that's going to be real similar to the one I gave you in the last assignment. I can't remember if I think I just swapped a part number on the last one so that you wouldn't have the exact one we were using yet, just so you could get more practice. So don't assume that this is the same part numbers I gave you before. It may be, I can't remember, but just don't shoot yourself in the foot by just using the same data sheet you had before. This may be slightly different than the one I gave you last week. So go ahead and find the data sheet for that so you have it available to use in your schematic when you're connecting up on your input side. You'll need that. Okay, and so those are all the part numbers you need, and then I'm just telling you you're going to have 2 normally open push buttons, so you don't really need any data sheet or information about that. One of them will be green and one of them will be red, and they're illuminated, so they're going to have inputs. They're going to be inputs on the push button side, and then they're also going to use the LEDs from them as outputs on your PLC. Okay, and then you're going to have 1 toggle switch, and it is a what's called on, off, on. So that means it's 3 positions. In the all the way one direction, it's going to connect common to one output. In the middle, it's not going to connect the common to anything. And then in the down position, it'll connect common to the opposite from what it connected here. So basically you have 2 normally open switches that share a common. So you're going to use that. So that just to be clear, that means that's 2 inputs on your PLC. One for up and one for down. But they'll share a common. Okay, I think that's all the devices that I want you to use in the schematic right now. We will be adding more. There's actually up to 6 push buttons on this, and eventually we'll add an analog input, some more toggle switches, but this will get us started here. So on your input and out diagram, I'm going to give you some guidelines so that everybody uses the same terminals and whatnot. So for inputs, input 0, 0, I want that to be your red normally open push button. For input 0, 1, we're going to make that your green normally open push button. And then we're going to skip to input 8, and we're going to have that be your toggle in the up position. Input 9 will be your toggle in the down position. And then I've told you which terminals. I haven't told you whether syncing or sourcing. These are just contacts, right? So you could wire them in either configuration. Let's say we'll do these ones syncing and do these ones sourcing. Okay, and then the last input, I'm going to leave that up to you, 0x. So x is going to be either 2 or 10. So you're going to pick for the proximity sensor. So you're going to use it as either input 2 or input 10, depending on whether it can be syncing or sourcing. You're going to have to figure that out on the data sheet. So that'll be one of those there. Then for outputs, now let's say output 0, 0 will be our red LED. So again, remember LED schematic symbol. Okay, and output 0, 1 will be our green LED. Oh, actually, I'm sorry, I forgot. I want to save those ones for high-speed things later. So we're going to make that 4 and 5, and then 6 will be relay 1, and 7 will be relay 2. Okay, so that'll get you all the connections for the PLC, but I do want you to go a little bit further in your schematic and show me how you're going to wire relay 1 and 2 to reverse the DC motor. So I want a complete schematic that goes through the 2 relays and to the motor. So it ends up, feeding a motor with positive, negative, or vice versa, depending on how the relays are turned off and on. So this is one of those examples where I'm telling you there's lots of resources out there how to do it. I just start searching on Google reversing DC motor with a relay. There's 2 most common varieties of how to do that. Okay, we're almost done with the assignment. The last part is going to be to create a very basic program in Connected Components Workbench so that we can test these inputs and outputs that you've used. So what I want you to do is create a basic program that when you press the green push button, it's going to set a bit to turn on a light. So turn on either green or red LED. So how are you going to decide which one turns on, green or red? If the toggle, so if toggle is up when the push button is pressed, then turn on green. If the toggle is down, you're going to turn on red. Okay, and those are set bits so that they stay on after you hit the green or red push, after you hit the green push button. Then if light is on, if either one of them is on, then a press of red PB turns them off. Okay, so toggle switch basically determines which light is going to turn on when you hit the green push button. Hit the green push button, the light should stay on until you hit the red push button. I guess we need one more to test our proximity sensor. So say if proximity sensor is on, then turn on, let's say, we'll turn on relay 1. And that's just a direct output bit. It's not a set reset. So the relay will only be on when the proximity sensor is activated. Actually, we'll do relay 1 and relay 2. So they both turn on in that case. And that'll just test our everything we've got connected. I think that'll test both push buttons, test the toggle, uses both lamps and both relays. Okay. So I hope that assignment makes sense. Please feel free to email me if you have any questions. I'll be available to get together on Zoom tomorrow. I will look forward to seeing you guys in person on Wednesday. Watch for an email from me tomorrow. I will be splitting us into 2 groups and have half of you come at 8 a.m. on Wednesday and the other half of you come at 10 a.m. so that we're not crowded in the room as you pick up your trainers. Plan to be there for a while in case you have questions. I may have you go over some basic wiring stuff while we're together just to make sure everybody's comfortable with what you'll need to do. But yeah, let me know if you have any questions. I will see you Wednesday, half of you at 8, the rest of you at 10. So check your email tomorrow to figure out when you should be there. Thanks. See ya.